All right, also going to do 34 once again, just so you guys have it. An arrow is shot from a height of 1.5 meters towards a cliff of height h. It is shot with a velocity of 30 meters per second and an angle of 60 degrees above the horizontal. It lands on the top edge of the cliff 4 seconds later. A, what is the height of the cliff? B, what is the maximum height reached by the arrow along its trajectory? And C, what is the arrow's impact speed just before hitting the cliff? Let's draw this out. Say he's on a platform that is 1.5 meters high. Okay, have our archer there, and then he uses this bow, bam, and he shoots this along a trajectory, and it lands like this on a building. And we are looking for the height of this building. All right, and it is launched along the horizontal at an angle theta of 60 degrees with an initial velocity of 30 meters per second. Okay, I think that those are, and time equals 4 seconds. So the first part is asking what is the height of the cliff? All right, so to find this, we can solve for our initial velocity in the y direction. So we'll do everything for part A in red. Part A, find hy. Okay. So, like I said, first thing we got to do is find our v naught y, which is equal to v naught sine theta, which is equal to 30 sine 60, which gives us an initial velocity in the y direction of 26 meters per second. Okay, so now using this, we can figure out the height. So, y equals v naught t plus 1/2 at squared. Remember, our acceleration is negative 9.8 meters per second squared. And we have, and it took 4 seconds, we have time. Time equals 4 seconds. So we plug all those in. We get v naught y here, by the way. So we put 26 meters per second times 4 seconds plus 1/2 times negative 9.8 meters per second squared times 4 seconds squared, which gives us a height of 26 meters. But we have this 1.5 here, plus 1.5 meters. So the total height, hy, equals 27.5 or 28 meters. And then for part B, we want to know the highest point at which it was along its trajectory. So that would be right there. To find that, we simply use our equation. Part B, hy equals v naught y squared over 2g. Simple enough. Just plug in our v naught y and our g. Remember, g is positive in this case. When it's g, it's positive. When it's a, it's negative 9.8. So that would be 26 meters per second squared over 2 times 9.8. That's meters per second squared, which gives us a total height of 34 meters. That's part B. Part C. What is the arrow's impact speed just before hitting the cliff? So we have to find our VF for both y and for x. So remember, in the x direction, we have no acceleration, correct? So what our initial velocity is in the x direction is the same as our final velocity in the x direction. So let's solve for that. So v naught x is equal to vfx, which is equal to v naught cosine theta, which is 30 cosine 60, which gives us a velocity of 15 meters per second. in the x direction, both initial and final. Now for the y direction, vfy, we have to solve for that. We can use any equation. We have acceleration and time now. Oh, we had time since the beginning. So that would be v naught y plus a t, which would be v naught y was 26 minus 9.8 times 4, and that equals 13 meters per second, negative 13 meters per second. And then we solve, we're looking for VF, which would be V naught VF x squared plus VFY squared, and we square root it. So that would be 15 squared plus negative 13 squared, square root that, and we get 20 meters per second. All right, and that is 34.